Okay, so welcome today, folks. We're going to be taking a look at how we find zeros using the P over Q and synthetic division of a function, polynomial function. So here we go. So we're going to start off first of all identifying what P is. P is our constant term, and Q is our coefficient of our first term. Well, I know what P is. P is 30. So I got to break down 30 into all the factors, multiply to give you 30. That's 1 and 30. That's 2 and 15, 3 and 10, 4 doesn't work, 5 and 6, 7, 8, 9, I'm back to 10. So these are all the factors that multiply to give me 30. And then Q, I'm going to use all the factors that multiply to give you 1. Well, that's just 1 and 1. 1 times 1 is 1. So it's just 1. Okay, this will make it for a relatively simple situation to set up our P over Q, which is going to be our possible. These are our possible factors. I'm going to do plus or minus so I don't have to write it each time. I have plus or minus. I have 1 over 1. Then I have 30 over 1. Then I have 2 over 1. I have 15 over 1. 3 over 1. 10 over 1. 5 over 1. And 6 over 1. So I've got all those. Okay, and basically what are these? This is 1, 30, 2, 15, 3, 10, 5, and 6. And it's positive or negative. Okay, so I'm going to start out using a little synthetic division here to try to find out. What I'm doing is I'm going to pick one of these possible zeros, and I'm going to use synthetic division. I'm going to use synthetic division, and I'm going to try to figure out whether it works or not. If it works, then that's a 0. If it doesn't work, then it's not. And what we use is this thing called the remainder theorem to figure it out. Okay, the remainder of it is 0 using synthetic division. We're good to go. If it's not, then we got to move on. So here's what we're going to do. Okay, I'm going to start out, I'm going to try to use 2. So I'm going to try to use a possible 0 of 2, and I'm going to set up my synthetic division. I do that just using the coefficients, as long as it steps down by 1 each time with the degree. So I've got 1, I have 1, negative 11, negative 5, and positive 30 there. Draw my line down, drop my first value down there. 2 times 1 is 2. Okay, 2, 1 makes that 3. 2 times 3 is 6. Makes that a negative 5. Okay. 2 times negative 5 is a negative 10. Okay. Negative 10. And then I've got a negative 15 there. Okay. And then 2 times negative 15 is a negative 30. What do I get here? I get 0. This is what I want. This means that this is a factor. Okay, or that this is a solution, this is a 0. We could set it up any way we want, really, when we take a look at it. So now I know one thing. I know that x minus 2 is a possible factor of this. I know that 2 is going to be the 0. So it's like setting it equal to 0, adding 2 to each side, you get x equal to 2. Okay, see how that works, how we get, that's the 0. 0 is the solution. This is the factor. So now I'm not done yet because I got to figure out what I have left here. So what I have left is I have, okay, and I'll set this up over here. I have x minus 2 times the quantity, and then this is just step down 1 degree. So instead of x to the 4th, this is going to be x to the 3rd. Then that's going to be plus 3x squared minus 5x minus 15. Okay, we can see here that we've got another polynomial. You could try to factor it by grouping. In fact, I think it works by grouping. Okay, I think it does work by grouping. Let me get the 15 in here. I guess we can't really see it, so I'll back it up here. There we go. Okay. So it's all right there. So yeah, you could factor it by grouping. So as soon as you get it to a point where you can factor it, go ahead and factor it, because then you can find the zeros by setting them equal to 0 and solving. But if you can't, okay, you're back to the drawing board again. And let's just pretend for the sake of doing this that, okay, I have my synthetic division here, I have 1, 3, -5, and -15, and I got to find another 0. Okay, so I got to go ahead and I got to find another 0. So I got to pick another one of these. Let's see, I might pick, let's try to pick -1. Let's see if it works. Okay, so we're going to try -1. So set it up here. -1 times +1 is -1. You get 2 left over there. -1 times 2 is -2. -7. Get +7. You see, you don't get 0 here. Okay, you're going to get -8. This is a no. Okay, so I know that -1 does not work. So I'll go ahead and I'll take that off, and I got to try it again. And this is where we kind of go on a little trial and error here. Okay, we'll try another factor here. We'll try another 0, I should say. And let's try -3. Let's see if -3 works. Bring this down here just like this. Okay. -3 times 1 is -3. Makes that a 0. -3 times 0 is 0. Makes that -5. -3 times -5 is a +15, which zeroes out. So this one works. So now I know that -3 is a 0. So now I know that I have, of course, I've got x minus 2, but now I actually have x plus 3 as a factor along with x minus 2. And again, how do I know that? It's just the opposite sign of how we do that because we're setting this equal to 0 to solve. If I set that equal to 0, I take 3 away, I get x equals -3, and that is my 0. Okay, this is my factor, x plus 3. Okay, so what do I have left? Well, again, I step it down. It was third power, so now this is second power. This is x squared plus 0x. We'll just keep that out of there, and then -5. Okay, so now I've got my factors. This is all factored out. Okay, so now all I got to do is set each factor equal to 0 to figure out what my zeros are. The other factor is x squared minus 5 equal to 0. Add the 5 to each side. X squared is equal to 5. Square root each side. Okay. X is equal to plus or minus square root of 5. So these are my zeros. Okay. So here they are. Plus or minus the square root of 5. -3 and +2. Those are my zeros right there. Okay, and that's how you use the P over Q method and set with synthetic division to figure out what your zeros are.